Alright, Unit 4.08, we're going to identify the effect on the graph of algebraic transformations of sinusoidal functions. So that's a lot going on, but what we want to remember is that we're dealing with sinusoidal functions, looking at sine and cosine functions, which are going to repeat themselves, and now we're going to look at the different things we can do to transform those functions. So, if you remember, sine and cosine, they're pretty bland. There's not a lot going on, and we want these to model real-life situations. So what we need to do is think about the different ways that we can manipulate the functions so that they can model our real-life situations. So we want to get a grasp of them algebraically, meaning looking at how the different changes to our function will affect the graph, so that when we're looking at real-world situations, we can kind of quickly put together a function to model a situation. Or if we know the function, we can tell a little bit about the situation. So the first thing that we're going to do is we're going to finish up the work from Friday. So here I've just rewritten the general sinusoidal form that you should already have, and we want to think about the changes, or what the changes to a, b, h, and k will do to the function. So we're going to go ahead, what you're going to do is you're going to go back to this website here, illustratedmathematics.org/illustrations/1647, and you're going to complete table A, table B, table in part A, the question in part B, and the table in part C. So what your work will look like is you'll have the table with a bunch of different entries in part A, you'll have your answer to part B, and then you'll have in part C another table with a bunch of entries as well. When you've completed that, and that should only take you another maybe 5 minutes or so, you're going to want to go ahead and for A, B, H, and K, you're going to want to try and say what changing this value will do to your graph. So, for example, we've already seen that if you change A and you make it, say, 3, the amplitude is increasing, right? The maximum and minimum values are increasing. K is pretty easy to see as well. When you're increasing K, if you have sine of x plus 2, well, that's increasing the y-intercept, or translating it upwards 2 units. So go ahead and do that, pause the video, we'll come back and we'll talk briefly about it, and then we'll move on to a more rigorous definition. Alright, so thinking about what the coefficient A will do, you might have said the word stretch in your work. It tends, when I change A, it's causing the maximum and minimums of the graph to get bigger and bigger. And so the way to think about that is, that sine and cosine, well, the largest value that sine or cosine can ever have is 1. So the largest value that your graph could ever have, if you had, for example, just 2 sine of x, well, the largest value that you could possibly have is now 2. So the changing in A will stretch, and you may have said that this also affects the amplitude. Alright, we'll leave B alone for a second, and let's go take a look at K. So in changing K, you may have noticed that this translated your function either upwards or downwards. And you'll notice that to translate it upwards, obviously this is going to be a positive value, and to translate it downwards, it's going to be a negative value. So if I'm translating it upwards, that means K is positive, and if I translate it downwards, it means K is negative. Alright, the next one is H. When you manipulate H, you'll notice that I am translating, I use white again, I'm translating the function left or right. Let's go left or right. So let's just consider that you had sine of x minus pi. So in this case, our h value would be positive pi. And so think about what that does to your function, right? Now, in order for you to get sine of 0 in here, what does x have to be? Well, in order for you to have sine of 0, x will have to be pi. So this means that you're going to have to travel pi radians. Your x value have to be pi before you can actually kind of start your function. So if you think about where the sine function starts, and thinking about it starting at an angle of 0 radians, well, you'll need an input of pi in order to actually get that. So this would move it to the right. So if you have a positive h value, you're moving it to the right, and if you have a negative h value, you're moving it to the left. Ironically, if you think about having a negative h value, so you'd have sine of, let's think about h being negative pi, you'd have x minus negative pi, which would be plus pi. So here, h would be equal to negative pi, and it would be shifting to the left pi units. Okay. Lastly, let's go ahead and talk about b, and you'll notice that when you change b, you're bringing let's imagine that you made b 2. You would be bringing the maximum points closer together. So if and I think in one of your examples, you tried b with a value of 2, and you'll see that this actually brings the maximum points twice as close together. And that, of course, will affect the period of your function. So what I might say is this compresses the function. And how does it compress? Well, it compresses the function in a horizontal way. So this is horizontally, right? Okay. All right, now what we're going to do is we're going to actually go ahead and define the period, amplitude, so on and so forth, using these values. All right, so we want to talk about the midline, amplitude, period, and then there's a couple things here that I haven't mentioned yet, but that will make a lot more sense based on these things here. So first, let's talk about the midline, and what we want to do is we want to be able to look at our function and say, okay, based on the values of a, b, h, and k, what is our midline going to be? So pause the video right now. This is going to be a little different. On the right side of your paper, I want you to, and maybe make this a little smaller, I want you to try and, on your own, explain how you would find the equation for the midline based on the values of a, b, h, and k. How would you find the amplitude based on the values of a, b, h, and k? Same with the period, and think about what phase shift and frequency will mean. Then go ahead and press play again, and we'll make sure we have the correct answer. All right, let's start with the midline. So what you'll notice is that when you translate your function up or down, it changes where the midline is, right? So if I had sine of x plus 2, all of a sudden my midline, if I have a xy graph here, so if I have sine of x, I'm just looking like that, the midline is y equals 0. But if I were to translate it upwards, now I have something where it looks like that. And so now the midline has moved up however many units I've moved upwards. So translating it by changing k is going to change the midline, and in fact the midline is then just going to be the line y equals k. The amplitude is pretty easy to see as well. The amplitude is just affected by whatever a is. So we saw that when we changed a to 3 or negative 3, the amplitude all of a sudden became 3 or negative 3, right, as the distance away from the midline of the maximum point. And so the amplitude is just the absolute value of a. Notice that we have to say absolute value because when a is negative, that doesn't mean our amplitude is negative, right? It just means that we are actually reflecting. If you notice this, we reflected our function when we make this negative or positive. Because the amplitude is the absolute value of a. the period, well, we noticed that when we changed b, that we were increasing or decreasing the period. And in particular, when we made b a bigger value, we were decreasing the period. So if you remember, when we have just a basic sine function or cosine function, the period was 2 pi. But when you changed b to 2, the period all of a sudden decreased and became pi, or was cut in half. And so you might think that we divide by b, and that would be correct. Your period is simply 2 pi radians, because that's what it normally is, divided by the b value. So the higher the b value gets, the smaller the period will be, or the closer together the maximum points are. Phase shift. I spoke about this briefly. So you might imagine phase shift just like we saw some examples of translating in the left or right direction. That's a phase shift. So the phase shift is just how many units have I translated either in the left or right direction. And remember that h determines how far we go in the left or right direction. So the phase shift is just the value of h. And then lastly, the frequency. And I want to talk very briefly about frequency. The easiest way to think about the frequency, and let me go ahead and just graph a sine function like this. So the frequency is the number of full cycles that are made in every single 1 unit. So if you're thinking about a sine curve like this, it makes a full cycle every how many radians. So if it starts at 0, it will make a full cycle, go through all of the possible values after 2 pi radians. So how many cycles does it make? How many full cycles does it make every 1 unit? Well, it makes 1 out of 2 pi full cycles. And so that's just for regular sine, right? But imagine if you were to make the period smaller. So maybe you changed it to something like that. Now all of a sudden it's making a full cycle in a much shorter distance, and the reason is because the period has been changed, because the b value has increased. And so what you're going to do to find the number of full cycles that it's making, or the number of cycles it makes every 1 unit, you're going to take the value of b, and the absolute value of b, I'm sorry, and we're going to divide it by 2 pi. And it should be reminded that this is also supposed to be the absolute value of b. The same reason that a had to be the absolute value for the amplitude, whether it's positive or negative, isn't going to change the period or the frequency. And so you might think of period and frequency as being the inverses of each other, right? So the period is 2 pi divided by absolute value of b, and the frequency is the absolute value of b divided by 2 pi. And frequency, I guess we should just define this here, is the number of full cycles that occur every 1 unit. Every 1 unit. Alright, so now that we know how to find the midline, amplitude, period, phase shift, and frequency, we're going to get a little practice looking at a couple of functions and figuring these things out. Here we go. So for the function y equals 3 sine of x minus pi over 4, indicate the amplitude, period, midline, frequency, and phase shift, then graph the function alongside y equals sine of x. Alright, so go ahead and find those things. Make sure that you're going back and trying this on your own. In order for you to learn, you're going to need to give these a try. You might get them wrong. That's okay. Make sure that you show your guess or your attempt, and then also I will talk a little bit about this one, and so you can update your answers with the correct work, and then we'll have one more for you to do all on your own. Alright, so here we go. First, let's just quickly go over the amplitude, midline, period, phase shift, and frequency. So the amplitude, of course, is the absolute value of the A coefficient, which is 3. The midline depends on the vertical shift. So there's no vertical shift here. There's no K value, so it's y equals 0. It's the midline. The period is 2 pi because the B value is 1. And if you think about it, the distance between maximum values is 2 pi. So this would be negative 1 and a fourth pi, and this is positive 3/4 pi. So that's a distance of 2 pi. The phase shift is pi over 4, right? I'm translating it to the right, pi over 4. So if you think about regular sine, right, when I have sine of 0, I'm at 0. Well, now to get to sine, to get 0, I need to plug in pi over 4, because pi over 4 minus pi over 4 will be 0. And so, in other words, the first root will be at pi over 4. The frequency, how many full cycles do I go through every 1 unit? Well, that's 1 divided by 2 pi, because the B value is 1 here. So 1 out of 2 pi every unit. Right, then I graphed sine of x, and you can see sine of x compared to 3 sine of x minus pi over 4, right, you'll notice that the amplitude has increased, it's been stretched, right, vertically, it hasn't been compressed at all horizontally, but it was shifted to the right pi over 4 units, and that's why the maximum points are pi over 4 units further along. All right, I'll have one more for you to try on your own, and then we'll take a look in class. Alright, so here you go. Here's a slightly different function. Go ahead and give it a try. I will give you one brief hint in about 15 seconds. So pause now, go ahead and try this out, and then after you're done, go ahead and press play again, and I'll just give you a couple things to think about for this question. Alright, I hope that went well. There's one thing that you want to consider, and that is looking inside the argument here of cosine. Notice that I have 2x minus 2 pi. So here we've got to think about, okay, well, is there a b value? And there is a b value because I've multiplied x by 2, so the b value must be 2. But you've got to factor out the 2. So the argument inside of your cosine now, once you've factored it out, should be 2x minus pi. And this will clearly show you, so here is the b value, x minus h. Okay, and this will allow you to better compute. And what you do is you could just plug in some values for x. You know, think about when x is 0, when x is pi, when x is pi over 2, 3 pi over 2, and that will allow you to see it as well. But it can be helpful to notice that there must be a b value because x is being multiplied by something. That's the b value, so you've got to factor it out then to find your phase shift. Okay, I will go ahead and make some changes if you need to, and I will see you on Monday.